Hi, it's CNT120. We are working on Chapter 4 on protocols. So we're going to look at a number of different TCP/IP core protocols. I'm going to try to show you a bunch of those as we're going. And as we do our lab this week, you'll get your hands on a number of these protocols as well. So hopefully between all of those methods, some of these will sink in and make some sense or be able to sort them out. All right, so let's dig in. First thing we need to remember is TCP/IP is basically a protocol suite. It's a bucket of protocols. If you want to send a file, there's a protocol for that. If you want to send an email, there's a protocol for that. If you want to receive an email, there's a protocol for that. So think of it as literally a giant bucket of protocols that each protocol has a focus or a purpose, if you will. This was developed by Department of Defense in the 60s, if you will, for ARPANET, which was the precursor of the internet as we think of it today. The advantage of this is its open nature. Pretty much any computer, any system can use this. Once upon a time, things were proprietary, but nowadays, pretty much any device, laptop, desktop, etc., phone, no matter the operating system, no matter the hardware, can run TCP/IP. So therefore, as we look at today, most things have it built in and or installed from the get-go. So if we take a look at, here's a screenshot from one of our lab PCs. If we take a look here, this is literally TCP/IP version 4 and TCP/IP version 6 installed on there. So those protocols are available to use and are usable. If we take a minute and I'll look at my PC real quickly. I'm going to open up the network settings on mine. Let me just slide it down here so you can see. Here's my network status, if you will. I'm going to go to network and sharing. In here, I'm going to look at I'm just use my Wi-Fi connection here that I'm using. If I open this guy up and look at the properties of this one, I will see that TCP/IP version 4 is installed and TCP/IP version 6 is installed. So since they're installed, I'm able to use those protocols. I'm able to communicate using those protocols. So if I were to open my command prompt and ping 127.0.0.1, remember that's your IP version 4 loopback. What that basically tells us is TCP/IP is installed, my computer understands it and is able to pass back and forth IP version 4, TCP/IP version 4 traffic. If I now do a ping space -6, ::1, the loopback for IP version 6, it replies with that as well, as if to say, yeah, TCP/IP version 6 is installed. I'm able to communicate using that bucket or that set of protocols as well. That's what that loopback is really doing. I kind of use the example of if you just installed a new doorbell in your house, you typically reach out the door and hit the button to see does it work. This is doing the same thing. TCP/IP is installed. Is it working? Is it functioning? Yes, indeed it is. That's what that's actually telling you. So let me close these out. So that's the first thing we want to recognize. TCP/IP, it's basically a stack of protocols. In this chapter, we're going to go through a whole bunch of those protocols. There are 4 major layers to the TCP/IP model. It takes the 7-layer OSI model and kind of condenses it, if you will. If we look at OSI model on the right, application, presentation, session, transport, network, data link, physical. These are the layers we learned back in Chapter 1. If we look at that in comparison to the TCP/IP model, it takes some similar layers and combines them. So our upper layers of the OSI model, where we really just had data that was formatted and ready to go, TCP/IP says, you know what, let's just call that whole thing the application layer. Transport is identical. Network they call internet. And then the bottom 2 layers of the OSI model, where our network card is and the connection to the network, whether it be a physical cable or wireless Wi-Fi signaling, if you will, that network card is giving us access to the network. It combines these two and says, okay, that's network access. So basically putting my NIC in there is these 2 layers, the MAC address and getting access to the network, and then the actual physical connection, whether it be a cable or radio frequency signals. So the OSI model adaptation TCP/IP is it's fairly straightforward, if you will, of combining the obvious layers together. The TCP/IP is routable. Some early protocol stacks were not routable, and certain networking protocols that got used were not routable. TCP/IP is, and we should remember that as we are moving data from like our browser down through to get prepared to send, we are adding headers for each of these distinct layers. Transport network, data link layer are adding headers so that they are readable on the other side. Okay, so thinking back to what we talked about in Chapter 1 with data encapsulation, you know, if I have a piece of, let's say I'm going to request a web page, my web request, layer 7 is data, layer 6 is still data, layer 5 is still data. That's why in the TCP/IP model they kind of combine those three layers into one. As it moves to layer 4 and TCP or UDP gets used, in this case with HTTP traffic, it is going to be TCP. The TCP header gets added to indicate, hey, this port number, this process, this service running on the server is the one I want to talk to, either port 80 or 443. Port 80 for HTTP, 443 if it's HTTPS. As we move to layer 3, we typically now have an IP header. That is getting out on the front, so this traffic, this packet can get routed through the network to the correct network, routed through a series of networks to the correct network and get delivered to that network. I always use the example of, you know, the York campus of Hack as opposed to the Gettysburg campus of Hack. That's what your IP header, the IP address is getting used for. At layer 2, we're adding the Ethernet header because most times we're sending data out across an Ethernet network, so there will be an Ethernet header added to it with the MAC address and so forth. And then layer 1 was our binary bits sending it out across the network. Hopefully that all sounds familiar again from Chapter 1. And then we have this where this graphic that we use where if I'm sending, this process is going this way and encapsulating, it moves across the network, and the receiving end is going to decapsulate. It's going to start taking those headers off and reading each header and examining, is this for me, is this for me, is this for me kind of thing. And then here was our names. Data segment packet frame bit, don't send fill for bill. So recall all of those back from Chapter 1. And then again, the receiving end is going to decapsulate. It's going to take that, receive it off the network, pull the Ethernet header off, and basically say, is this for me? Yep, okay, keep going. Pull the IP header off. Is this for me? Yep, keep going. Pull the TCP header off and go, hey, is this for me, and what service? Oh, this is going to the browser. So, you know, it's port 443, so it's going to go to the browser. We will send it to the browser on the computer as opposed to the email application on my computer. With TCP/IP protocols, we typically talk about a device by its highest OSI layer that it reads. So a switch is typically going to read MAC addresses at layer 2, so we typically call our switches a layer 2 switch, if you will, just kind of the ordinary switch that we would have. A router is typically going to read the IP header, layer 3, so we typically call a router a layer 3 device. Firewall is typically going to read your TCP header for these port numbers to decide whether this traffic should be allowed through or not. So we typically call a firewall a layer 4 device. So as we're dealing with equipment in TCP/IP networks, we usually refer to them as the highest layer that they read and or, you know, examine that data. The highest layer that examines and reads and makes decisions on where that traffic goes. All right, when we come back in the next podcast, we'll take a look at TCP.